states of matter. As far as the general states of matter, the concept is concerned, तो सबको पता होता है. So we are not going to go into those details, but we are going to cover some broader aspects, such as if we talk about gases. So we know gases have no arrangement of particles. Then what else they have? They have no intermolecular forces. They have random motion of particles. They have no shape and volume of their own, right? Then we can talk about liquids. So liquids may they have layered arrangement. Their particles are touching each other. They are in contact. Then liquids are incompressible. There are no spaces between liquid molecules. And sliding motion is observed. That means liquid particles, they can basically move on across each other. Intermolecular forces in gases are almost zero. Yes, you can say they have weak intermolecular forces of attraction, but in your examination questions, they can ask you about that. Which of these states of matter have no intermolecular? So the answer should be gases in that case. Okay. Hassan, are all these points clear? Can I change my slide? Then if we talk about solids, so in solids, particles are tightly packed. Then the second case is particles have vibratory motion. Particles have no spaces between them. And they have strong intermolecular forces. Now, basically, we have to deal with the changes that happen when we change, when there are different states of matter, they interchange. So that is what we plan to study. So if we start up the discussion with, for example, a solid. So particles are initially, they are vibrating. They're all vibrating. They have vibrations. So they have vibratory motion. So if we start to heat this up, what happens? So step one, the vibratory motion increases. That's the step one. So that this step one basically is very important. This increases the temperature, and we can say kinetic energy of particles have increased. This is what we can say. Okay. But this is still not melting. This is basically becoming a water solid. So before it reaches its melting point, that is what we get this part. Step two is where solid starts to melt. At this point, the potential energy increases and kinetic energy stays same. That means the particles now start to gain spaces, but their vibration stays same. So this process is very important that we have to understand potential energy increases. So initially, if solid particles were like this, they had no spaces between them. But when you have, a space between them, that's where they have higher potential energy. That is what is to be understood very clearly. Yeah. So the understanding is vibration is happening even here. Okay. Vibration is happening even here. This is happening here. But the extent of vibration is same. Only they're pushing each other apart. So they're getting apart, but the vibrations intensity is same. That is important. So it's kind of, you know, they have more space between them, but the vibration, the energy they initially have is the same. That's important. Do you get this part now? Because that's melting. So during melting, kinetic energy doesn't change at all. Reason is the energy that is provided to the substance is consumed by intermolecular potential energy. So they don't have any energy left to increase the kinetic energy. Where I show time on x-axis and temperature on y-axis. So initially, when you start heating a solid, so temperature increases. So at this point, we can say it's a cold solid. At this point, we can say it's a hot solid. So what's happening? As time is increasing, temperature is increasing. Okay. Then what next? Step two is where it starts to melt. So that's what happens. So temperature is no more increasing. This is melting. This is where only potential energy is increased. We get this part? Yeah, yeah, exactly. Now, the same happens with, a liquid, and the same happens with a gas. So step one, if we have a liquid, So let's sketch a liquid molecule. So let's say that's liquid particles. So step one, once you start to heat this up, what happens? So the layered motion increases. That means you see particles basically flipping among the layers. Layer one is moving up, layer two is moving down. That's what's happening. Yeah. That is only. So that in turn increases the kinetic energy. So we can say kinetic energy increases. Okay. But no change in potential energy. That's important. And temperature increases. So what happens next? In a step two, what happens? They start to move apart. So they gain spaces, increase in potential happening. So no change in kinetic energy. That means temperature stays constant. Do you get this part? Yeah. Initially, when you start heating a substance up, whether a solid or a liquid, it won't be that the solid starts to melt immediately. So initially, it starts to become hot and hot and hot. So where it doesn't melt, the time, the temperature before melting is my step one. Same goes for a liquid. So once you start heating a liquid, it only becomes a hot liquid. But then a solid reaches a temperature where it can melt. That's a step two. Or where a liquid reaches a temperature it can boil is a step two. Do you get this? So you don't have to memorize what is the step one and what is the step two. But I want you to learn the understanding that heating happens in two processes. In step one, it basically only heats the same state. So now if we continue with that heating curve, we move here. So what happens next? So here we have a liquid. So liquid becomes, hot. So liquid cold and liquid hot. So this is only heating. So that's kinetic energy increase. But beyond that, where it basically has reached to the maximum point, then it starts to boil. So here there is only increase in potential energy. You get this? Yeah. So when you are basically heating a liquid, okay, what's happening? Initially, its temperature increases. Okay? Initially, its temperature increases, right? So if you basically, let's say you have a container, just give me a minute. I'll show you something that will help you. मजा आया. It's basically what you see here. Can you see my screen? So this represents solid happening. So solid is doing what? You see vibration happening. Okay? Okay. So this is solid happening, and there is vibration happening. Okay. So we start to heat this up. What happens? What happens? Then you start to cool this up. What happens? So there are two changes that's happening. First one is yeah, particles are basically moving apart, right? So let's say if I start to heat it gently, so only what happens? Only the motion increases, right? They're not leaving each other. So only the motion increases. That's a step one. But once you heat it higher, so you see there is a temperature change happening. There is a thermometer right on your screen. So it says 8 Kelvin, 7 Kelvin, and whatever you see here. Okay. So let's do it in Celsius. So then what happens? So if you start heating this up, temperature is increasing, increasing, increasing. What's happening? It is basically converting into a gas phase, right? So now the particles are spaced up. They are moving apart. They have been apart, right? So they have higher potential, right? They get this. So that's the general understanding here. That's one part of it. So for example, if we have a liquid, we start to heat this up. This boils up. Start to cool this up. This becomes a solid. Okay. Let's say we have a gas. We start to heat this up. Particles, they have more energy. So particles are going to collide more rapidly. Only kinetic energy. Yeah. If we start to cool this down, so particles motion is going to, decrease. They get this? Is this understood? That's step one. Now let's study phase changes. So on here, you see there is an interaction potential. There is basically, a phase diagram which is going to help you understand the concept of, kind of uh, state change. So let's see how it goes. So let's use water, for example. So initially, this is liquid water. Okay. So if we start to increase the temperature, what happens? Initially, see, only particles are basically vibrating faster. They are not moving apart. So you can say the temperature is increasing and thermometer is showing us an higher temperature. Okay? Right? But they are not boiling. So that is where temperature is increasing. That is it. Do you get this? So it's step one. Step two is where they're going to break apart. So that's where potential energy will increase. Okay? And you'll see that there is no change in temperature diagram. Do you get this part? So now they have started to boil off. So temperature is almost constant. It is not increasing at that much faster, which it should have been. So that's one of the. We can compress it. So that's a state change. That's something else. Then we can release this pressure. We can bump this down, higher pressure. So particles are going mad. They're going to kill us. Less pressure. Okay. So this is a gas representation. आप इसे कूल कर देंगे तो मॉलिक्यूलर पार्टिकल्स बिल्कुल बिल्कुल खत्म ही हो जाएंगे पोर्शन. हीट कर देंगे तो इनिशियली टेम्परेचर बढ़ेगा फिर नहीं बढ़ेगा. So if we study the interaction, what's happening? So let's see potential energy and distance between. So if we increase the potential energy is increasing when you increase the distance, right? And if you bring them closer, what happens? Kinetic energy increases, potential energy decreases. ठीक है. अब वो दूर इसलिए चला गया क्योंकि वो आपने बहुत ज्यादा पोटेंशियल उसका बढ़ा दिया. अब वो दूर चला जाएगा. Do you get this? अब तो कंफ्यूजन नहीं है कोई. लिंक भी मैं आपके साथ शेयर कर देता हूँ. आप अपने पीसी में डालना, सेलफोन में डालना, फिर आपको ज्यादा मजा आएगा. दैट वुड बी परफेक्ट. अब अगर मैं आपसे ये कहूँ कि ओके हीटिंग तो हमने कर लिया, कूलिंग करते हैं, तो हाउ वुड यू ड्रॉ अ कूलिंग साइकिल? लेट्स से आपके पास बेसिकली you have steam and you're cooling it becomes water, and then you're cooling it becomes ice. तो इसका कूलिंग का ग्राफ कैसे बना? Then I was waiting कि how would you draw this cooling curve? I drew a heating curve. I started heating a substance up. So how would you draw a cooling curve? Any ideas? Exactly, you flip this diagram upside down. That's how you do it. क्या मतलब? So for example, if we have steam, ठीक है? So सबसे पहले this is temperature. Gas cools, ठीक है? Then gas condenses. It changes the state. Then it becomes liquid. Then basically liquid freezes here, and then it becomes solid. That's the cycle. So this was gas cooling. So you see temperature is decreasing. That's where gas converts to liquid. So gas condensation happens. That's where liquid cools. That's where freezing happens. That's where solid cools. So exactly उल्टा हो गया वो. Yeah, that is what I said कि गैस से शुरू करो सॉलिड तक जाओ. ये तो हमें जाहिर है क्वेश्चन कुछ बताएगा कि हमें किसको सॉलिड तक लेके जाना है किसको नहीं लेके जाना है लेकिन यहाँ पे हम नहीं एज्यूम. यू अंडरस्टैंड इट. दैट्स नाइस. तो हसन लेट्स कीप इट अप टिल हियर. मैं आपको ये देता हूँ आप इसको थोड़ा सा रिव्यू करना. उसके बाद इंशाल्लाह ताला नेक्स्ट क्लास में फिर हम बातें करेंगे. तो आई थिंक मंडे और थर्सडे फिक्स कर लेते हैं. बाकी स्टूडेंट्स अगर नहीं है तो मेरे लिए थर्सडे काफी कन्वीनियंट है. आप क्या कहते हो? सी यू इन द नेक्स्ट क्लास. टेक केयर. अल्लाह हाफिज.